what about the actual books? So this is the book they use. This is the 3rd grade book. In the 3rd grade book, I open up page 1, and what they're doing immediately. Now, so this is not the reference book. This is the problems. This is where they're doing problems. And on page 1, right away, they want them to multiply. 1 times 1, 2 times 2, 3 times 3, 4 times 4. And yes, it's not just the standard algorithm. You're supposed to be counting the dots and noticing this pattern. But right away, then you're moving on to other products. On the next page, here's some estimations. Use about the 3 times circle rule. For any circle, the circumference is about 3 times the diameter. The point is to estimate the way we really do. And the idea, again, is pi, such a mysterious number to students. My college students right now are so mystified by pi. Pi, the mysterious number, it's just about 3. If people would understand it's just a little bit more than 3, they could have some common sense about pi. They could use it instead of treating it like this mysterious force. Multiplication, division, facts. Oh, here's another one. 7 baskets, 9 apples per basket. How many apples in all? Okay, standard problem. But it's in this context of multiplication. I like this one. I don't like calculators. I think calculators should basically be out. But this is the kind of calculator problem I hear. Use your calculator. So enter 469. Enter 469. Change to 1,469. And then how? So the question isn't take 2 numbers and add them together. It's you have the number 469. You want to change that to 1,469. What you do? It's not going to clear and then retype it. You add 1,000. What about this one? 1,059 to 859. What do you do? The student I got this from got this one wrong. Thought you subtracted 800 then added 1,000. Hey! Oh yeah, that would be adding 200. If you had subtract 1,800, that would have been a clever solution. So, anyway, these are the basic problems we're seeing. You're not seeing, first of all, the most important thing I think is this is all multiplication. These students are learning multiplication. Let me turn to one of the pages that gets into, so they don't really tell you how to multiply, what method to use, you just do what you are doing. They do eventually get to the kind of multiplication that MJ is talking about in her video, if I could ever find it. It's quite a bit in the book, well after they've done all sorts of multiplication the other way. And now they're getting into fractions and math boxes. Fractions. There is a subject that tortures students in college to this day, and probably adults everywhere who have to deal with fractions. But they probably don't deal with fractions because they just pull out a calculator. But if you ever bothered to figure out the fractions, here we go. You know the problem. So here's the partial products algorithm. So now they're getting into the one where you do 7 times 46 by doing 7 times 6, 7 sixes or 42, and 7 40s for 280, and then you add them together. The very common sense algorithm that's really behind the standard algorithm, and that many people come to on their own, is in here. And then there's pages of that, and then there's more pages of partial products. So quite a bit of practice with these algorithms. They do eventually get into the one that drove her crazy. But again, there's an awful lot of just multiplication. Doesn't matter what you do. Here it is, lattice multiplication. This is the one that bothered so many people, or one of the things that bothered so many people. And what I find interesting with this problem is, it says Megan has a special way of doing multiplication. She calls it lattice multiplication. Can you figure out how she does it? It's not telling them to do it this way, and just you have to do it another way. It's actually asking them to figure out how she does it. So if a student can figure out this lattice multiplication from these clues, you've got 3 practice problems and then figure it out yourself, then they've really figured out how to think about math, how to think about multiplication. That's what we want. We want students to master these skills. There's plenty of time for mastery in here, but to think about it, and finally, and most importantly, to connect it to something that makes sense to them in their context. They must master these skills. Absolutely, I agree, they should master these skills. But mastery of skills without understanding is useless. And my argument again of why it's useless is because I see these kids today in college who have mastered the skills but cannot apply it to anything. They know the quadratic formula, minus b plus or minus square root of b squared minus 4ac over 2a. They all know that. Well, I don't know if all of them do, but many of them know that. But they don't know when to use it. They don't know what it's for. How many people do? What is it for? Can you think of a real-world situation? I can, but this is my career. How many other people have used the quadratic formula? Is that what we focus on? What can we focus on that would be best for the students, for the majority of students, and for the highest ones? What can we do for them too? Everybody. I suggest that These books are not to blame for the state of mathematics today, of students' math. First of all, the problems predate these books. Secondly, these books are fine. But how they're taught, that's a different story. How parents react to them matters, how students react to them, and how teachers react to them. And also if the administration's shoving them down people's throat, that doesn't help either. But the books themselves are quality.